Hey guys, welcome back to another How Not to Fail with Tommy J. Today we'll be focusing on rectangular and polar representation of a sine wave. Okay, now with the general sine wave equation for AC voltage, you would have the amplitude times the sine of angular frequency times time plus the phase angle. However, if we move over to polar form, you just have a radius and an angle. Much simpler. And if you move down to imaginary, you have the real plus the imaginary. Now, you can see here in the blue, we have a basic sine wave with an amplitude of 7. In the red, we have another basic sine wave. However, it is shifted to the right by 70 degrees. Now I will show you how to represent this equation in polar format. First, you want to find your RMS voltage. To do that, you divide your amplitude by root 2. That equals 4.95. Next, you want to add on your negative 70 degrees. And there you go, you've got your polar format. Now, to represent this graphically as a vector, you would have a magnitude of 4.95 and you would have an angle of negative 70 degrees. Now, rectangular representation. Use the same RMS voltage we found before, 4.95, multiplied by the cosine of your angle, negative 70 degrees. This equals 1.69. Now, similarly, use the RMS voltage again, 4.95, multiplied by the sine of your negative 70 degrees. Now, this equals negative 4.65. Now, to put this all together, to get your rectangular format, you have your real 1.69 plus your imaginary minus 4.65. Add your J on. Now, once again, to represent this visually, we have an imaginary and real scale. It goes down at 4.65 on the imaginary and it comes across 1.69 on the real. Now, you can see that you would be able to find the angle here and the magnitude to turn this back into polar format. Sadly, we do not have enough time in this video, so you're going to have to comment if you would like to see that.
Nice.
Or just buy yourself one of these Casio calculators for a quick $80, and then you won't have to do anything I just taught you.
Oh